We're going to go ahead and talk about angles. For the next 3 chapters, we'll be talking about angles. OA is your initial side. Point O, where the two angles come together and intersect, is referred to as your vertex, with OB being your terminal side. Your angle always starts at your initial side and rotates, you see the arrow there, towards your terminal side. Our angle that we have here is in standard position. An angle in standard position has its initial side on the positive x-axis, which we do have here if we would put our angle on our xy axis. A positive rotation, like this here, basically rotates counterclockwise. A negative rotation would start at your initial side and then rotate backwards to get to your terminal side. A negative rotation rotates clockwise. Then we have quadrantal angles. Quadrantal angles start and end at the axes. So we're going to have our initial side here. We're going to rotate, and this would be a quadrantal angle of 0. We'd rotate up here to get this. That would then be an angle of 90 degrees. We could then rotate to our next axis. That would be another quadrantal angle. You get 180, and you keep doing that. You could go all the way around and get to 360, but that's going positively. Keep in mind you could start here and go negatively, so you could rotate back to this, and it would be negative 90. So then you'd also have negative 180. And so on. So there's infinitely many quadrantal angles. A coterminal angle is an angle in which has the same initial side, but a different terminal side. So we need to go ahead and rotate this. We need to come back to another spot right here. So if we go back and rotate this back to another spot that's starting here, we're going to start out here. We could rotate all the way around and then come back up. Go all the way around once is 360 plus that additional 30 would be a 390. You could also get a negative 330. A negative 330 would start out with your initial side here and then rotate backwards clockwise, which is a negative angle, to 330 degrees negative. You could also get a 750. A 750 would start here. It would rotate around once to 360, rotate a second time around to 720, and then go your 30-degree angles. So there are many coterminal angles. Basically, to get a coterminal angle, you need to add or subtract 1 revolution. So if you're dealing with degrees, which we are now, you would add or subtract 360. Acute angles are between 0 and 90 degrees. Obtuse angles are between 0 and 180-degree angles. Complementary angles are two angles that add up to 90 degrees, while supplementary angles are two angles that add up to 180 degrees. When you're dealing with length, you could measure something in feet, inches, meters, centimeters, kilometers, or miles. To measure distance, you have different units you could use. To measure volume, you have different units you could use. Well, in measuring angles, you also have different units you could use. You are used to using degrees. Another unit of measure for angles is called radians. Angles can be measured in degrees or radians, does not make a difference. We now have 25 degrees, 43 minutes, and 37 seconds. Kind of the apostrophe means minutes. The 37 with the quotation marks means seconds. Now, most of you are familiar with converting hours, minutes, and seconds either into all hours or taking part of an hour and converting it into minutes and seconds. It's the exact same process for converting degrees, minutes, and seconds, because in 1 degree there's still 60 minutes, just like there is in 1 hour there's 60 minutes, and in 1 minute there are 60 seconds, just like it is for time. We need to go ahead and convert our 25 degrees, 43 minutes, and 37 seconds into degrees. Well, we know it's going to be 25 degrees plus a part of a degree. So when you're looking at your 43 minutes, you'd have to convert that. Well, it's only part of an hour, so you're going to have to divide it by 60. 43 minutes is part of an hour. It's also part of a degree, so you're going to divide it by 60. You're going to use the same process either way. When you are looking at your 37 seconds, you need to take your 37. You need to divide it by 60 once to change it into minutes, and then you got to divide it by 60 again to get it into degrees. So basically you're dividing it by 60 times 60, or 60 squared. When you go ahead and just type this right here into your calculator, you will get this. Well, in math, we typically have a forwards way and we have a reverse way. We can do it one way and we can do it backwards. Here we have an angle with degrees and a decimal, and we now want to change that back into degrees, minutes, and seconds. The easiest way to do that is to make sure your calculator is in the degree mode. Once it's in the degree mode, you want to go ahead and type in your angle, then hit the second button, then hit your apps button, then select number 4. That's your DMS button. Means it will change it from our degrees into degrees, minutes, and seconds. After you have selected number 4, then you hit enter, and then it gives you this. The definition of a radian is that the central angle of a circle is subtended by an arc in length to the radius of the circle. That's the definition this book uses. I like the definition of another book which really accomplishes the same thing. It says take your arc length, divide it by your radius. Your arc length is this curved distance going around the outside. Your radius is, of course, going from the center out. And the measure of your angle is what we're talking about, the measure of this angle here. Now, whenever you see subtended in your book for your homework or on your review or on your test, think, oh, definition of a radian, just go arc length over your radius.